Okay, so next we're going to look at how to graph one-dimensional motion. So here you can see that I've drawn some axes, and the first thing I'll show you is a graph where the position is not changing. And in this case, you can see there's this flat green line that shows the position at 23 meters, and it never changes. So if the position does change, then it might be a graph like this where the position is changing with time, so the position is a function of time. And from this graph, we can determine what the velocity graph should look like. That is, we can graph the velocity as a function of time, and we can do that from its definition. So in this case, we're talking about what's called the instantaneous velocity. So that's different from the average velocity that I talked about in the last video. So that is the velocity that is equal to dx dt. That is, the velocity, the instantaneous velocity, is equal to the slope of the position graph at that moment in time. And in this position graph, the slope is changing, right? The slope is getting steeper and steeper as time goes on. So that means that the value for the velocity is also changing. The velocity gets larger and larger over time because the slope is steeper. So in this case, the velocity might look something like this. And in this case, I haven't bothered to put values on the vertical axis. And similarly, the instantaneous acceleration, which is the acceleration at some moment in time, that's the acceleration that's equal to dv dt. So the acceleration is equal to the slope of the velocity graph. In this case, the velocity graph has a constant slope. That is, the slope does not change. That means the acceleration is constant in time, so we would draw a straight line to represent the acceleration. And then we can actually also graphically represent or determine the average velocity. So that's basically just the average slope of the position over some time period. So in this case, let's try to determine the average velocity from 20 seconds to 50 seconds. We would draw a straight line connecting those 2 points and then determine the slope of that line. The slope is equal to the rise over run. That would be the change in position, delta x, or the displacement, divided by the amount of time it took, delta t. So the numerator will be 40 minus 12 because the position is about 40 meters at the final point and is about 12 meters at the initial point. And then the time would be 50 minus 20. The final time minus the initial time. And then work out the math, and it works out to about 28 over 30 meters per second. That means the average velocity from 20 seconds to 50 seconds is a little bit less than 1 meter per second.